Hey guys, welcome to my first lesson in calculus. This is a foundations course pretty much online. I decided to offer my help online for free, so I hope you like it. Before you begin, you should know that the prerequisites for this and basically any calc course is a solid understanding of algebra, geometry, and trigonometry. So if you're good on all those three subject areas, we can begin. Alright, our first lesson is going to be on something known as a limit, and limits are fundamental to calculus. Now here's a big fancy formal definition that we have here. I'll read it out to you. A limit is defined as a value that a function approaches as an index of that function approaches a value. Now that's just a big fancy way of saying that a limit is a value that you get as you get closer to a certain value. So basically, it is the y value you approach, or the y value that you're getting to as x approaches some value. So for example, we could have x going towards the number 3. So here we have a number line, 0, 1, 2, 3. And that's just saying as x gets closer and closer to 3, not quite at 3, but it's getting really close to 3, what is the y value going to be? You can almost think of it as, once x does get to 3, based on what is happening, what will the y value be? Alright, so limits are denoted by this sign, LIM, that means limit. So limit as x approaches, you use the arrow sign for approaches, and c is just some constant. Alright, so hopefully you get that. If you don't, just follow along with the examples, and hopefully you'll understand after these first few examples. So for the first example, we have find the limit as x approaches 5 of the number 5. So the function f of x is equal to 5. So f of x equals 5. Another way you could write that would just be y equals 5. Now you should be able to graph that very easily. So we have y is always equal to 5, so then we just have a horizontal line at 5. And I know I wasn't quite on my 5 mark there, but just pretend that I hit it. Alright, so we have our axes, and I should probably draw some more x values here. So we have 1, 2, 3, 4, 5. Alright, and we're trying to find the limit as x approaches 5. So that happens right here. X is approaching 5. So when x is getting closer and closer and closer to this line, what is our y value? Well, our y value is quite simply going to be 5, because for this function the y value is always 5. So as x gets close to 5, y is equal to 5. So the final answer to this question would be quite simply the limit as x approaches 5 of 5 is equal to 5. Not the most exciting thing in the world, but it is important that you understand the foundations. So we'll try to carry on and just go into our next example here. For our second example, we have the limit as x approaches 2 of the function 2x plus 2. So let's just draw that out like we did last time. So we have this graph, our axes, and we have a point 2, x is equal to 2. And the slope, 2x, so that's going to be fairly steep. And it's just going to go up and up and up and up and up. Alright, and we're trying to find the limit as x approaches 2. So as x gets closer and closer and closer to 2, which happens right here, what is our y value going to be? And I know I didn't draw it very well, but if you continue to go up, that would be 1, 2, 3, 4, 5, 6. And then they would kind of overlap right here. So as x approaches 2 of the function 2x plus 2, we would get a y value of 6. So we can just write that equal to 6. So hopefully you get that. Basically right now all I'm doing is solving for the equation, but you can't really think of it that way. You have to remember, we are approaching a value, and we're getting the value that we're approaching. So as we're approaching 2, we get a value of 6. now we're going to talk about something known as left and right limits. Now, I just gave you specific limits. I said the limit as x approaches 2. But it's possible for these values to be different depending on which direction you're coming from. If you come from the negative direction towards 2, it's possible that there could be a different value than if you came from the positive direction towards 2. For example, if we had a piecewise function at 2 and it jumped right here from some value to some other value, as you came from the positive direction, the value of y would be greater than if you came from the negative direction. And there are some other examples too where that applies. So basically, whenever it's coming from the left, we denote it as the limit as x approaches c, and then we put this negative sign in here. So it's the limit as x approaches c from the negative direction. And if it's coming from the negative direction, that means we're going from negative to positive. So we're approaching from the left, going towards the right. All right, and then just the same thing, but from the right, we're coming from the positive direction. So we say the limit as x approaches c from the positive direction, and we denote that with a plus. So that means we're coming from the right. So right, we're coming from the right, going towards the left. We're coming from the positive direction towards the negative direction. And a good way to remember this is by looking at the sign and saying from the sign direction. So if you're coming from the negative direction, there's going to be a negative. Coming from the positive direction, it's a positive. I don't normally think of it as being coming from the left or from the right. I think of it as coming from the negative or coming from the positive. It's just easier to remember, and you don't get things mixed up that way. Okay, so now we're going to look at a piecewise function, which is basically what I was just talking about. So find the limit as x approaches 5 from the negative direction and from the positive direction of f of x. So let's start by graphing. We have our graph, we have our values. So here's 5. And when x is less than 5, our y value is equal to -3. So x is less than 5, and our y value is -3. So we can just draw this in here. And when x is greater than or equal to, notice the greater than or equal to sign, then we have x, or y is equal to 4. So to do this, we need to have a closed circle and kind of draw that at 4. And I forgot I need to have an open circle down here as well. And if you remember from piecewise functions before, you should have drawn these at some point before in your academic career. But this is an open circle at the bottom. Whoa. This is an open circle at the bottom because x is less than 5. So once you actually get to 5, it jumps up to here and is equal to 4. So in other words, f of 5 would equal 4, not -3. So now I have to find the limits. Okay, so the limit, so the limit as x approaches 5 from the negative direction of f of x. And what's that equal to? Well, it would have to be either -3 or 4. And now we're coming from the negative direction. Remember that. It's negative. We're coming from the negative direction, going towards the positive. That means we are going from the left to the right. So if we look at this, coming from the left to the right, we find that it is approaching a value of -3 at the point 5, even though it never actually gets to this point -3 because it's an open circle. It's still approaching -3 from the left. And then likewise, limit as x approaches 5 from the positive direction, that would be coming from the right, going towards the left. and we would have an answer of 4 of f of x equals 4 because we're coming from the right, from the positive direction, going towards the negative direction. Alright, continuing on, we have another couple examples that I would like to get through. So for this example, it's just like the last one. We have another piecewise function, except this time we're using slightly different values. I'll go through this a little bit faster. It's essentially the same as the last one. Let me just draw my graph real quick. Alright, and this time when x is less than 3, so we go to point 1, 2, 3, our function is 3x. So what's 3x look like? That's just, that would be 0, 0, and it goes up 3 over 1, up 3 over 1, and it gets pretty steep. And we just draw it straight up like that. And once it actually gets to 3, we would have an open circle, and that would be at the point, well, it would be at 3, 9 is where that would occur. Alright, and then when x is greater than or equal to 3, our y value is equal to 4. So at 3, we have a closed circle, and then the line continues out this way at x equals, or y equals 4. So the limit as x approaches 3 from the negative direction, that's coming from the negative, going to the positive, that would be this point up here. That would be equal to 9, because we're approaching the point 9, even though we never get there, we're still approaching it. So as x approaches 3 from the negative direction, it would be 9. Likewise, limit as x approaches 3 from the positive direction of f of x would be equal to 4, because we're coming from the positive direction, heading towards the negative direction, and we meet at this point 4. That's the value we're approaching, and it's the actual value at that point. And now here's another about limits. For a limit to be considered true by itself, the limit taken from the left must be the same as the limit taken from the right. If it's not true, then the limit does not exist. In other words, if we go back to this example right here, the limit from the left was equal to 9, but the limit from the right was equal to 4. So what is the limit as x approaches 3 of that function? Well, that's quite simple. The limit does not exist. And we can just write DNE, that stands for does not exist. Because when you're coming from the left, it equals 9. When you're coming from the right, it equals 4. It does not exist. Limit of x as x approaches 3, not there. But if we went back up to one of our earlier examples, before I talked about the left and the right bounds, or left and the right limits, you could see f of x equals 5. So if you came from the right, it would be equal to 5. Came from the left, it would be equal to 5. And if you came from the right, it would also be equal to 5. So in this case, the limit is true, and you could just say, like we did say, the limit as x approaches 5 is equal to 5. So that's a case where the limits do exist, and this is a case where the limit does not exist. So we have two final examples before I wrap this lesson up, and I just wanted to let you know what happens as x approaches infinity, which is what you will see sometimes. You can also see as x approaches negative infinity, and it's basically the same thing. So we have this function, x squared, and that's just exponential. It just basically looks like a u or a parabola. So we have it going increasing, 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 and on the negative side, it's also increasing. So as x approaches infinity, well, that means it's going towards infinity. Infinity is way over here somewhere, and you never actually can get to infinity because it just goes on forever. But as x approaches infinity, what does y equal? Well, if x is going towards infinity, what happens to our y values? Well, our y values are also going way up to infinity. Just keep going up and up and up and up and up forever. So if we use logic, we can basically conclude the limit as x approaches infinity of x squared is equal to infinity. because as you go to infinity in this direction, you get to infinity in that direction. That's pretty simple. And likewise, if we were to say the limit as x approaches negative infinity, we would just keep going way up to the left forever, and our final answer for that would also be infinity. So that's fairly simple to understand, I hope. But it doesn't always go to negative or positive infinity. Sometimes it might go to a number, or it might even go to 0. So let's look at this final example here. The limit as x approaches infinity of 10 over x. Draw a graph. At 0, well, that's not going to exist, but at 1, we'll be up at this point 10. At 2, we're going to be at 5. At 3, we're going to be at 10/3. And so on and so forth. And eventually, we're just going to keep getting closer and closer and closer to the line. Zoom in, and oops. We never actually touch the line, though. We just get closer to it. So no matter how far you go, it's never actually going to touch the line, or the horizontal axis. So the limit as x approaches infinity of 10 over x, we go way out in this direction with our x values, and what happens is our axes and our line just get closer and closer and closer and closer and closer, but they never ever touch. So this means that our y value is approaching 0, because they get closer and closer and closer and never touch. Alright, that wraps up our first lesson. I hope I was somewhat useful. In our next lesson, we're going to talk about how to do this algebraically, which is pretty easy. So I hope you have some understanding of limits now. And if you don't, hopefully you'll get them by the next lesson. Alright, thanks. Have a good one.